All right, so in today's lesson, we are extending our knowledge of polynomials by looking at what division looks like for a polynomial. You have done polynomial addition, subtraction, and multiplication. We kind of reviewed that, but today we're looking at division. I think you might have done a little bit of division in Algebra 1, maybe, depending on your Algebra 1 experience, but we'll go over it again here. Okay, here are a few key concepts. A polynomial can be divided by another polynomial of a lesser degree. So we're dividing larger polynomials by smaller polynomials, right? Kind of makes sense. That's how division goes. If there's a remainder, it's added to the end of the quotient. Quotient, that's an answer to a division problem, a quotient, right? So it's added at the end as a fraction over the divisor. Remainder over divisor. Okay, now synthetic division is a type of division that is possible for linear divisors, and it's really ideal for linear divisors with a coefficient of 1. So like when you're dividing by 1x plus or minus a number, okay? When you're dividing by that, then synthetic division is fantastic. Otherwise, long division should be used. The next concept here, each term of a polynomial should be present in the division process. If a term is missing, then you should use a 0 as its coefficient. So for example, look at this, 2x cubed plus 3x minus 5. Which term is missing? The x squared term there. So look what I did. I put a 0x squared in its place. Okay? You have to do that for both the thing you're dividing and what you're dividing by. No missing terms allowed. Okay. A polynomial, this is a key one right here. A polynomial is always evenly divisible by its factors. Okay, that means that we have a remainder of 0. Always. That's always true, right? And that really shouldn't even be very crazy for you. Think about when, back when I make you make factor trees, right? What's a factor tree of 24? Well, it's 2, 12, and 2, 6, and 2 and 3. Okay, so what are the factors of 12 or 24? What can we write 24 as? We can write it as 2 times 2 times 2 times 3. That's what 24 is, right? That is the factored form of 24. Have you ever thought about that? It's 24 written as all its factors multiplied together, right? So that's what a factor tree is doing. It's helping you get a factored form of a number. And how did we know that all of these things were part of the factor tree? Well, because you're doing division. So when you're doing factoring, you're kind of doing division, aren't you? And you're doing division with a remainder of 0, things that are evenly divisible, okay? So factors are inherently, by definition, evenly divisible. All right, that last point here, if f of x is a polynomial function in standard form, then f of a, right, f of a number is what you would get when you plug that number in, okay? But it also is the remainder that you would get if you did the function divided by x minus that number. We'll kind of see that a little bit later on in this lesson. Okay, so first things first, let's just review the division process. What does division look like? So we'll zoom in here. Let's do a really simple division problem from elementary school just to kind of exercise those muscles again. We'll do like 561. No, I don't want that. 62 divided by 3. Divided by 3. Okay, so let's review the steps for division. How many times does 3 go into 5? Look, I know you know how to divide. I'm trying to do this so I can connect these steps to what you're about to do, the polynomial division. So how many times does 3 go into 5? 1 time. What do we do with that 1? You multiply it down to the 3, and that's what fuels the next line. 1 times 3 is 3. And then what do I do with that 3? You subtract. Those steps are going to pop up in polynomial division. Okay, 5 minus 3 is 2. And then what do? I bring down the 6. Another step that's going to pop up in polynomial division. And then what do I do now?
8.
I start over. 3 times what goes into 26? 8, right? 3 goes into 26 8 times, and I do all the same stuff again. 3 times 18, or 3 times 8, is 24. Subtract, and we get 2. And bring down that last digit. 22, how many times does 3 go into 22?
7.
7. 7 times 3 is 21. And we subtract, and we have a remainder of 1. That's your remainder. When you have no more digits to bring down, that last part is your remainder. How do we write the answer when we do division? Well, we can write it as 187 with a remainder of 1. That's a serviceable way. 187 and 1/3, right? You remember doing that? Writing it as a mixed fraction, right? The remainder over what you divided by, 1/3. And then any mixed fraction can be written, really what's happening is it's 187 plus 1/3. When I say 187 and 1/3, I mean 187 plus 1/3, right? That's what we're talking about. Okay, so that's 3 ways to write your answer. And really, this way is going to connect best to what we do with polynomial division. All right, so that's crash course reminder of how to do long division. Let's apply those steps to polynomial division. First of all, let's set it up. 3x squared, cubed, sorry. 3x cubed plus 17x squared plus 21x minus 11 is being divided by x plus 3. So first, you need to focus in on the largest term, x and 3x cubed. And in elementary school division, you asked yourselves, how many times does this go into that? But here, you should rephrase that question. Instead, as what would I have to multiply this by, x, to turn it into 3x cubed? What would you have to multiply x by to turn it into 3x cubed? What is it? Well, it's definitely an x squared to turn an x into an x cubed. And then what about the 1 into a 3? A 3, okay. And then multiply that down. When you multiply it, it has to distribute to both terms, okay? Like what's happening is 3x squared times x plus 3 distribute to both. All right, and that is feeding the next line. Okay, so 3x squared times 3x is 3x cubed. 3x squared times 3 is 9x squared. And then here's how you set up the next part. You're going to subtract, but what are you subtracting? Each column. You are subtracting each column of like terms. So subtract, like that. Okay. Or maybe if you learn this another way, some people say change the sign and add, which is the same thing as subtraction. So it's really not different. Okay. So subtract, the first column is always going to cancel out. 17 minus 9 is 8, allegedly, x squared. And then you bring down the 21x. And you start again. What do you have to multiply x by to turn it into x squared? What would you have to multiply x by to turn it into 8x squared? X. And the 1 into 8 would take an 8. So 8x. Okay. And then you're multiplying that. Distributing it. And that's what's feeding the next line. 8x times x is 8x squared. 8x times 3 is 24x. Subtract. The first column cancels. 21 minus 24 is negative 3x. And bring down the minus 11 one more round. What would you have to multiply x by to turn it into negative 3x? Negative 3. And multiply that. So you get negative 3x. That's what feeds this next line. Negative 3x minus 9. Subtract. The first column cancels. You have negative 11 minus negative 9. What is minus negative? Yeah, that turns into plus. So this really is plus 9. Minus negative 9 is plus 9. What is negative 11 plus 9? Negative 2. Cool. Nothing else to bring down. That is your remainder. So how do we write our answer? 3x squared plus 8x minus 3 plus negative 2, the remainder, over x plus 3, this wonky looking fraction at the end. Okay. That is how we write our remainders in long division. If you're cool with that, go ahead and try number 2. If you're not cool with that, well, you don't have a choice. You still have to try number 2. So just go ahead and try number 2. Okay. Okay. And just try to set it up. Baby steps. Try to set it up first. There's your setup. Check your setup. Check your setup before you get wrecked up. See what I did there? So, and then watch your exponents there. Looks like I fudged and I put at x squared should be x cubed there. Okay. So, there's your setup. And then don't get thrown off by how large the thing that you're dividing by is. You're really only focusing in on the largest terms. What do you have to multiply x squared by to turn it into x cubed? Just an x. Okay, finish this one out, and as you finish up, check your answer up here. So there's one round of division. Notice you have several minus a negative going on in there. When you subtract each column, minus a negative turns into plus. Okay, if it's going well, carry on. There's your final answer as you finish up. That's what I got at least. So your remainder over what you divided by. And then here off to the side, I'm going to write a couple of examples of unique ways that some people write their remainders. So these are just unique examples. Maybe your answer was like, I'm just making this up, x minus 2 plus, it was a remainder of negative 7, when you divided by something. Some people would write it like that. I will write it like that. I will always say plus, and then the remainder on the top over what you divided by. But some people would write this as, because they don't like to do plus a negative, they like to combine those. So some people would write it as x minus 2 minus 7 over x minus 4. They will bring that negative down in front of the fraction. And I get that. I would just be careful if that's going to be your habit. Because if the remainder has multiple terms, that negative would have to come from both terms or all the terms. So here's an example where we have multiple terms in the remainder. Maybe the answer was x minus 2 plus, negative x plus 3 over x squared minus 7. Something like that. And they were like, ugh, I don't like that negative up there. I'm going to bring it out to the front. Here's what they'd have to do. X minus 2 minus x minus 3 over x squared minus 7. That negative has to be factored out. If you're going to bring that to the front, it would have to be factored out of the entire numerator. Both terms, changing both of their signs. You see what I mean? So that's why I don't actually do that rule. I'll just go ahead and keep it like this all the time. Plus the remainder over the divisor, regardless of sign. Okay, but now you've seen it, so now you're not going to freak out if you ever see that happen. So that's nice. Okay. Long division is not the only type of division. Synthetic division is fantastic for situations where you're dividing by x plus or minus a number. Something like that. Okay. And it's also possible, when it's like 2x plus or minus a number, or 3x plus or minus a number. Okay. But it is a little more difficult in that case. So let's see how synthetic division works. The first thing we're going to do is we're going to take the solution of x plus 3. The solution. What is the solution? Well, it's what you get when you set it equal to 0 and solve. So x equals negative 3. We're going to take that, and that's going to be our corner number or our multiplier. Okay. So we have negative 3 as our corner multiplier. And then we're going to take the coefficients of the thing we're dividing. So there they are, the coefficients and their signs. So if it's minus that term, then that is a negative coefficient. What if a term is missing? What should you use? 0. You have to put a 0 in if that term's missing. Okay, and then the rules for synthetic division go like this. You add down, and then you multiply back up. What are you multiplying by? The corner number, that multiplier, the negative 3 in this case. Okay, that's our multiplier. So here's how we start. Start by adding down. 3 plus nothing stays 3. That first coefficient is always going to come down. 3 plus nothing is 3. Cool. Times negative 3. 3 times negative 3 equals negative 9. Awesome. And then we add down. 17 plus negative 9 is 8. And then we multiply back up. Times negative 3 equals, again, times negative 3. 8 times negative 3 is negative 24. And then we are adding down again. 21 plus negative 4 is negative 3. And then multiplying back up times negative 3 is negative 9. And positive 9. Sorry, positive 9. It's okay. It's all right. Just calm down. Yeah. Okay. So adding down, negative 2. That last number is our remainder always. Sometimes it's 0. It's very significant when it is 0. Sometimes it's not, and that's okay. All they asked us to do is divide, so it's okay that we have a remainder that's not 0. It's fine. So our answer, the remainder is negative 2, and the other numbers on the bottom are the coefficients of the answer, the quotient. So the first one is the constant, right? Just like 11. You know, 11 was the last coefficient, and it didn't have an x. So our last coefficient doesn't have an x. It's the constant. And then we have x, and then x squared. You know, keep it going until you've given each of those coefficients a variable. So our answer here is 3x squared plus 8x minus 3 plus negative 2 over x plus 3. The factor you divided by was x plus 3. Okay, I know negative 3 was the corner number. That's not what you put in the answer. You put what you were dividing by, not its solution. Okay. There you go. That's synthetic division. It's kind of nice, right? Just add down, multiply up. Add down, multiply up. So when you can use synthetic division, most people will. And again, the cases where you definitely want to use it when it's just one x plus or minus a number. So, all right, let's set that aside for a moment, and let's talk. I'm going to skip number 4 for just a moment. I want to talk about these next set of instructions. Factor the polynomial completely by using the given information. Now, I hinted in the intro that factoring and division are really just two sides of the same coin. Okay? When you make a factor tree, you are using division in your brain. Okay, so you already have an instinct for this. So when I tell you something like, looking at number 6, f of negative 5 is equal to 0, that is my way of telling you, or when I tell you on number 5, 2x minus 5 is a factor, that's my way of telling you something about the remainder. What am I telling you about the remainder when I say 2x minus 5 is a factor? What is the remainder going to be if you know it's a factor?
0.
0. When I tell you something is a factor, I'm telling you the remainder that you can divide that thing out of the polynomial, and the remainder had better be equal to 0. But I'm not going to tell you the remainder is going to be equal to 0. You have to know that that is true because I said it's a factor. Okay? And you also have to know that there are a variety of ways that I can tell you that the remainder is going to be 0. 2x minus 5 is a factor, is not the only way to tell you that. Here's another way of telling you that. Let's take a quick example like y equals x squared minus 3x minus 10. The factors of that are x minus 5x plus 2. So I could say, okay, guys, x minus 5 is a factor, and that's your way of knowing the remainder is going to be 0. Or x plus 2 is a factor, and that's your way of knowing the remainder is 0. But couldn't I also say, okay, guys, x equals 5 is a solution, or x equals negative 2 is a solution? When I call those solutions, well, then you know that those solutions make this a factor. And if this is a solution, then that means this is a factor,
I'm still not sure.
and it's evenly divisible. Okay? So I could give these to you as factors, or I could give them to you as solutions. What are some other names for solutions? These are solutions, zeros, roots, x-intercepts, okay? So I could call them any of those words, and they all mean that it's x equals that number, and therefore you have a factor coming from that that is evenly divisible with no remainder. Last, why do we call it a zero? We call it a zero because it's when you plug that number in, it makes 0, right? In this little made-up example, 5 is called a 0 because when you plug a 5 in, you get 0. It's crazy. So, or negative 2 is a 0 because when you plug it in, you get 0. So, I can call it a factor. I can name its solutions. I can call them solutions, roots, x-intercepts, or zeros. Or I can write them as zeros in function notation. F of that number equals 0. F of negative 2 equals 0. What does all of this mean? The remainder is 0. All of this means remainder equals 0. Okay? All of it. We got that? All right, cool. Well, let's tackle number 6. F of negative 5 equals 0. What am I trying to tell you? That negative 5 is, it's a 0. X equals negative 5. What would be its factor? X plus 5. That's the factor that makes this 0. Okay? And when I do division, what should I expect? That the x plus 5 is my denominator, or what I'm dividing by, but what's the result going to be at the very end? What's the remainder going to be? 0. Okay, let's test it and see. Am I putting a 5 or a negative 5 in the corner? Negative 5. I put the solution over here, negative 5. My coefficients are 6, 1, negative 117, and 140. Go ahead and do your synthetic division. You try it. Check your answer with me when you're done. Five times 29 is 145. So you get your remainder of 0, right? 5 times 28 is 140. Get your remainder of 0, which is exactly what was supposed to happen. And that confirms to you that way over here, x equals negative 5, yeah, it turns out it is a 0. That is true. And x plus 5 is a factor. Okay, so here's our polynomial function as it currently exists. The known factor, the one that we just proved, x plus 5, not x minus 5, that's the solution. It's x plus 5, the factor. And then what? 6x squared minus 29x plus 28. Does that satisfy the instructions? Read the instructions. Well, first of all, it started out as f of x, so it really needs to stay f of x equals. Don't rob it of its identity. It's a function, f of x equals. But what do the instructions say to do with this polynomial? Factor it completely. Is this completely factored? It's partially factored, right? 6x cubed was not factorable. And you might have been like, well, what about grouping? Okay, yeah, grouping is great sometimes. Sometimes it works on a cubic, but not on all cubics. This is actually not factorable currently with our set of tools. So we used division to help us get started. We need to finish factoring this, though. The 6x squared, that's a quadratic. We need to finish factoring it. Try your x chart or whatever method you use to factor it, but you factor that. Okay, and then look up here when you're done factoring it. There's your final factored form. Check it when you're done. Okay, so if you did the x chart and factoring by grouping, you'd be looking for factors of what, 378? No, 168. Factors of 168, and I think it's 8 and 21, isn't it? Yeah. 8 times 21. So that's how you work in the x chart if you're going that route. Check your answer when you're done. All right. Hey, there's one more thing I want to show you today, for now, and it's number 4. Okay. Number 4. We're dividing by 4x minus 3. And this is a little different. Let's follow our procedures and see where this goes. So the first thing we do is we would find the solution of what we're dividing by. So add the 3. And then how do we get the x alone? Divide by 4. Cool. It'd be 3/4. So 3/4 is that corner number, the multiplier. And then we'll go with our coefficients here. Oh, there's a little missing parentheses there. We'll fix that. There we go. 4, negative 11, negative 6, and 9. Okay. And then you have your little bar there. And we just have to work with fractions. We have to multiply. Our multiplier is fractions. So 4 plus nothing is 4. Cool. And then 4 times 3/4. What is 4 times 3/4?
3.
Yeah, it's 3. And there are a couple of ways to think about that. First, you could do 3/4 of 4 and just think about what is 3/4 of 4. It's 3. Or you could multiply 3 times 4, 12, and then divide by 4. Okay, that's 3. Or you could divide first. You could go 4 divided by 4 is 1, and then times 3. Okay. So a couple of ways to think about that. But it's 3. Plus negative 11 is negative 8. 3/4 times negative 8 is negative 6. Plus negative 6 is negative 12. And 3/4 of negative 12 is negative 9. Hey, if you're going to sleep, you can go to the back of the room and do it where I don't have to look at it, or you can go in the hall.
What's 3/4? Now you add down.
So 9 and negative 9 is 0. Okay. So here's the thing. Don't write this. Just watch. This is our answer. The factor that we just got, we proved, and what we have there. Don't write this down. 4x squared minus 8x minus 12. Is that a factored form of the polynomial we started with? Why not? How do you know it's not? How do you know it cannot be the factored form? Something's wrong.
You can divide all that up by 2. You can take out a 2x.
Nope. It's not the fact that it's divisible. It's allowed to be divisible. What is the problem? If things are factors, they should be able to multiply back together and make the original. What if you FOILed these back together? What's the first thing you're going to get?
16x.
16x cubed. Whoa. We only have 4x cubed. You see the problem?
Yes.
This is way too big. 16x cubed. That's way too big. What happened? Okay, so this cannot be it. I'll scribble that out there. Let's think about this. How about like a simpler division problem? All right, here, let's go off to the side and think about this. What if I was like, all right, guys, let's do 32 divided by 4. What is the answer? 8. Cool. What if I changed my mind and it was like, no, 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 no. Only divide by 2. What is the new answer? 16. When I cut what I was dividing by in half, what was the result of my answer? On my answer? It doubled. It doubled. So how would I have to fix that answer to get back to the original? I'd have to divide it by 2 because it's twice the size that it should be. If I cut my divisor in half, then my answer is going to be double. And so to fix the answer, I'll have to cut the answer in half too. That's what's happening in our polynomial division problem. When we solved and got 3/4, we cut what we were dividing by 4, by a factor of 4. We divided by 4, so we cut it to a 4th, which explains why our answer is 4 times too big. So when you're solving, the rule is, for fractions in synthetic division, in the solving process, whatever you divided by here, you have to cut your answer down by that same amount. Okay. You cut your divisor by dividing it by 4, so your answer is 4 times too big. You got to cut it down as well. Okay. So we cannot just attach x's to that. Instead, cut it first. 1, -2, -3. And then put your x's back in there. A word of the wise, we do not make this adjustment to the remainder. It is only the coefficients. Okay. We do not make this adjustment to the remainder because the way that we write our remainder, when we put it over the divisor, we're fixing that already in the way that we write our remainder. Okay? So we don't change the remainder. We don't have a remainder here, so it didn't matter anyway. X squared minus 2x minus 3. There we go. That is our answer. Okay? So, hey, for that reason, some people don't like doing synthetic division with fractions. And so the second they see that this is going to be like a fraction in the corner, they'll just go do long division. Because they're like, I don't want to have to fool around with fractions. I don't want to remember the extra rule. And that's your choice. I don't mind either way. Okay? But if you want to do synthetic division with fractions, you can. It's possible. It's not that bad. All right. That's as far as I want to go today. If you want, you can try number 5 on your own. Check your answer with the completed notes in Canvas. But I'm going to stop for today. We'll do the rest of this tomorrow.